Hey everyone and welcome back to the channel. Today we are diving into a cool optimization hint introduced in C++20, the likely and unlikely attributes. These attributes allow you to give the compiler valuable hints about which branches of your code are more probable to be taken at runtime. In this video I'll explain what likely does, how it works, when you should use it, and just as importantly, when you shouldn't. Let's break it all down step by step. First things first, likely is an attribute that you can use to indicate that a particular path in your code is the most probable one to be executed. This is especially useful in if and switch statements, where the compiler can use this information to better optimize branch prediction. Here is an example. In this snippet, we are telling the compiler, hey, it's more likely that the user is already logged in, so optimize accordingly. Why does this matter? Modern CPUs are fast, but one thing they don't like is guessing wrong. When there is a conditional branch in your code, the CPU tries to predict which branch will be taken. If it guesses correctly, everything flows smoothly. If not, there is a pipeline stall, which costs performance. By using likely or unlikely, you are giving the compiler a hint so it can organize the generated machine code to match expected runtime behavior. This helps the CPU make better branch predictions. There is also the unlikely attribute, which works exactly the same way, but for code paths that are rarely taken. For example, in this case, you are telling the compiler that it's unlikely this block of code will run, which helps it optimize the normal path better. How does this affect performance? It's important to understand that likely is a hint, not a command. The compiler can choose to ignore it if it thinks it knows better. Also, this doesn't change the logic of your code at all. It only affects performance in specific cases. That said, the gains can be noticeable in hot code paths where branching behavior has a measurable impact. For example, in tight loops that run millions of times, or in systems code where predictability is critical. You can apply likely and unlikely directly to conditional branches. This only applies to statements, not expressions or function declarations. Also, it's worth noting that if you write in the wrong place, the compiler will give you an error, so pay close attention to syntax. You shouldn't just sprinkle likely everywhere, hoping for speed boosts. If you misuse it, you might actually degrade performance instead of improving it. Worse yet, if your guess about what's likely is wrong in production, you are giving the compiler bad advice. So only use it when you are confident about the runtime behavior, or if you've profiled your application and found a clear hot path. Let's say you are building a web server. Most requests are handled without errors, but occasionally something goes wrong. In this example, you are telling the compiler that most of the time the request will be valid. Optimizing that case improves your server's responsiveness under normal conditions. To sum up, likely and unlikely are tools that help you guide the compiler's optimization decisions, but they should be used with care. They are most effective when used in performance-critical code where you understand the branching behavior. If used correctly, these attributes can shave off precious CPU cycles and improve the responsiveness of your application, especially under heavy load. Thanks for watching. If this helped clarify things for you, give the video a like, subscribe and check out the playlist on the screen. See you in the next one.